Today, I'm going to go over an inline version of the 4040 VSlot electric cylinder. While I like the pulley version for being so compact, having the motor inline just reduces parts and complexity. Fundamentally, this works the same as the previous version. The VSlot has an opening that fits an 18mm tube almost perfectly. So this acts as both a linear bearing as well as the body. The 12mm diameter of the nut fits inside the aluminum tube, and the square flange fits in the V-slot on a diagonal, so when the motor turns the screw, the nut is prevented from rotating and you get that back and forth linear motion. There's a link to the complete materials list in the description, but here are the main parts. 4040 V-slot, an aluminum tube with an outside diameter of 18mm and an interior diameter of 12mm, an Igus 1/4 inch high helix lead screw with a 1-inch lead, and their matching square flange nut, a coupler to mate the screw to the motor shaft, and there's a few printed parts. First, the motor mount. This is a NEMA 23. There's also a NEMA 17 version. On the other end of the V-slot, we have an end cap with a hole for the aluminum tube. And finally, there's a little cap that goes over the Igus nut. And I made this after running the previous version for a few weeks and noticed that the nut was getting grooves carved in from the V-slot every time it would change motion, change direction rather, the little gap in the V-slot to the nut was enough force. So anyways, after a few weeks, there was a few little grooves in there. So this cap just protects the nut, but more importantly, removes any of that extra space. So it's a much smoother transmission. The first thing I do is I cut a couple grooves in the end of the screw, and I just use a Dremel with a fiberglass disc. The grooves are there to hold a couple O-rings with a spacer in between them, and this keeps the spacer in the right place at the end of the tube, which provides support when that screw is inside the aluminum tube. Next, we need to put a couple set screws in the tube to hold the nut in place. I find it's easier to put the nut in the tube and then drill them both together. That's a lot easier for me than trying to line everything up separately. It's important though that you have to drill all the way through the tube for the set screw, but you don't want to go into the nut far at all. Just 1 or 2 millimeters is fine. You really don't want to get anywhere near the threads because you really don't want to damage those threads. I used a 2.5mm drill bit and tapped the holes out to M3 for the set screws. The set screws are lightly tightened to avoid squeezing the nut's threads into the screw. You don't want to provide any kind of clamping of the nut to the screw. You just want to hold the nut in place. The motor mounts are designed to hold a 1/4 inch flanged bearing And this supports the screw and prevents any of the off-axis force from transferring to the motor shaft. This is much more important for the NEMA 17 version. At the end of the tube, I tapped the 12 millimeter inner diameter to a 1/4 inch NPT, so it can easily add quick air adapters, which make it very easy to take accessories on and off. Next, after tapping both ends of the VSlot to M5, we can attach the mount and then the end cap with M5 screws. So we can put the tube into the V-slot, making sure the flange is lined up correctly. We can put the end cap So the next thing I do is put the coupler onto the screw. Okay, so now we don't have to worry about that side falling through. And we could put this end on. And finally, once this is all together, we can mount the motor. There we go. So the stroke on this is pretty decent, especially for its size.